My name is Ted Triplett. I'm the program coordinator for the Engineering Design Technology program. It's a new program, a couple years old, and it mainly teaches the computer programs in engineering fields, architecture, all those sort of things, as well as 3D printing. In this program, one of the things we do is engineering design. This project, was a perfect project for that type of course. Now, the project is a hand for a 6-year-old boy. He was born with just a small part of his hand, about an inch long. The hand's design is actually available online.
It was made to fit, a teenage child, not a very small child with very limited mobility, as Cooper had. We took it, we put it into 3ds Max. We used the user-created plane, scaled, made the plane the size of his hand, and then scaled every piece to what it needed to be in order to fit. From there, we printed the first, which is what you saw him get today, was the first one we actually printed. We started, we put it together with regular nuts and bolts at first. It wouldn't work. They grinded together. So we had to try to find something that would work. They didn't, of course, sell anything small enough, as small as the hand had to be, that we could drill a hole big enough through the hand in order to use. So we ended up using Autodesk Inventor, designing our own friction style pin, and pinning it together that way. That was our first major issue.
The problem then becomes making the hand work for Cooper, all right, the 6-year-old boy. The way this design is created, you can use your wrist to bend down your hand. When you bend down the hand, the fingers close. Well, if we think about Cooper, who is little, 6 years old, and then has a very small part of his hand, he has very little leverage to make this hand close.
Then we came into the issue with the cording in the hand. We tried to put elastic in both top and bottom. Well, it wouldn't work because when you manipulated the rest of the hand where it was elastic on top, it just stretched and the hand wouldn't close. So come to find out, we had to use a nylon type cording that wouldn't stretch. That way it wouldn't give and it would cause the fingers to close.
Also found that it's absolutely critical to make his wrist match up with the pivot point on the ABS hand. So we actually had to put a lot of work into that pocket that his little hand fits into. It had to be perfect size. At that point, he was able to move it for the first time. But we knew still, it was so hard for him. It wasn't practical still. So it was after that first fitting, we got rid of a lot of the friction. And the other thing we did was print a block that's not in the design anywhere. And we fit the block, inside the ABS hand. And what the block does is extend his hand, right, to make it longer, to give him more leverage. And it was at that point, during the second fitting, he was able to move the hand very easily. After that, it's just a matter of cleaning up the design, making it look prettier, and that sort of thing. We teach the old AutoCAD program that people still use, but we also teach you the 3D programs that are coming on now. We also go into other things like entrepreneurship, how to start a business, how to come up with an idea. We go into that and take that idea, from the beginning all the way to the product. People own businesses around here are very surprised at the skills that my students come out of here with. They get a very extensive and practical skill set, Our country has put a lot of work and time into 3D printing with the idea that we will bring manufacturing back to this country. People don't realize it, but it's already being used to create a lot of objects that are sold. And we know that the future of manufacturing is 3D printing in this country. The job is actually the creation of the files on the computer. Right? That's the job of the future, and that is what you learn to do here. Ready?